Alright, perfect problem 4 for Math 95. We're asked to find the union of two sets and the intersection of two sets. The first set is all x that satisfy this inequality here. Maybe we'll take care of that one first. It's saying all x so that 14 minus 2x absolute value is less than 20. The way you solve these absolute value inequalities is we first pretend that what in here is positive, in which case the absolute value signs don't do anything and we just get 14 minus 2x is less than 20. The other case is if what's in here is negative, in which case what the absolute value does is it multiplies all that stuff by a negative sign, so we put this negative out here. And now we have two inequalities to solve. So for this one, maybe if you subtract 14 from both sides, you get to here. And now divide by negative 2. Remember, dividing by a negative flips the inequality around and you get x is greater than negative 3. See over here, distribute the negative. And you get negative 14 plus 2x is less than 20. Add 14 to both sides. You get 2x is less than 34. And then divide both sides by 2. And you get x is less than 17. So set A, we need x to be greater than negative 3 and less than 17. So that's everything from negative 3 up to 17. And we can do something similar with set B. See, now it's 9 plus 6x. Absolute value has to be less than or equal to 15. Got our two cases. If this is positive, absolute value signs aren't doing anything. If this is negative, absolute value changes, multiplies the whole thing by negative 1. So that's this out here. And so now we have two inequalities to solve. See this one here, subtract 9 from both sides and you get 6x is less than or equal to 6. Then divide by 6 and you get x is less than or equal to 1. Over here, distribute the negative, and then add 9 to both sides, and then divide by negative 6. Remember, dividing by negative, you flip the inequality, you get x is greater than or equal to negative 4. So over here, we need it to be less than or equal to 1, greater than or equal to negative 4. So we're talking about this set right here. And now we want to know what's the intersection and union of these two sets. For me, it kind of helps to graph them, although you don't have to do this extra step. Let's see, maybe negative 3 is here, 0 is here, 17's way out here. Yeah, maybe that's all we'll do on this one. And then right below it, we'll put 0 in the same spot, but now we care about negative 4. And positive 1. So let's see, this set here is talking about everything from negative 3 up to 17, but not including those 2 points. And this set right here is negative 4, color that in, all the way up to 1, and we do want to include those 2 points, and everything in between. So let's see, what we want is, this up here is A and this down here is B. If we want, the question is asking for A union B. Remember, union means that you have to either be in this set or in this set. So all the numbers that are in either this set or this set, looks like everything from negative 4 up to positive 17. And we do want to include negative 4, but we don't want to include 17. And if we want A intersect B, those are the things that are in both this set and this set. So it looks like that's just the things from negative 3 up to positive 1. We don't want to include negative 3, but we do want to include positive 1. So those right there are your answers, and that's the end of the perfect problem.